Hello my dears, how are you all? So in the last class we discussed very important questions regarding the induction motors, especially that last question, in which direction the rotor will rotate and all. That's very important. That's really important questions. And I already told you the concept also, right? I already told you the concept also. Focus on the concept. Okay, focus on the concept. So today we are going to go to another session. It's also very important. Electromechanical torque developed. Torque developed. Electromechanical torque developed. Actually, this is a very big derivation. The equation for the electromechanical torque developed is a very big derivation. Only after that derivation we will get the value, the expression for electromechanical torque developed. But for competitive examination point of view, that derivation is not needed, right? That derivation is not needed. We just need the final equation. We just need the final equation so that we can play with that equation, right? We can play with that equation, or we can use that equation for problem solving, correct? So there is a final equation for the electromechanical torque developed is that TE will be equal to some constant KT into S into E1 square into S into E1 square into R2 divided by R2 square plus SX2 square. So this is the final expression for the electromechanical torque developed. I already told you this is actually a very big derivation. We don't want that derivation. Okay. So you know these terms. Here KT is nothing but torque constant. What is that? Torque constant, correct? And its value will be equal to 60 into 3 divided by 2 pi ns. Whereas ns is nothing but, my dear, synchronous speed, correct? Synchronous speed. Okay. And you know the remaining parameter E1 is nothing but the induced EMF in the primary, which will be nearly equal to what? V1, correct? E1 nearly equal to what? V1. And R2 is nothing but the rotor resistance. You know this because you already learned the equivalent circuit of induction motor, right? So I think you already familiar with this parameter. S is nothing but the slip, correct? S is nothing but the slip. So I am going to make a small change in this equation. Let or put alpha is equal to R2 by X2. Let alpha is equal to R2 by X2. So this equation will be slightly modified as KT into S into E1 square R2 divided by, I am taking X2 square outside, correct? I am taking X2 square outside from this equation. It will become R2 square by X2 square plus S square, correct? I'm taking R2 X2 square from outside of denominator, so it will become like this. So this will become KT into S into E1 square into 1 R2 by 1 X2 will become alpha divided by 1 more X2 is there. So X2 into R2 by X2 is nothing but alpha square, correct? Plus S square. So this is the final equation for the electromechanical torque developed. You want to remember only this equation, just this equation, because by using this equation we are going to play a lot. By using this equation. This is just a starter. This is just a starter equation, no? Need not to be remember all the time, but if you remember this, it's very good. Okay, because in if you go for a lunch in a very big hotel or a standard hotel, normally they provided with a starter, right? So like that, it's a starter. So you can use this equation and you can continuously doing some adjustment and you will get the final equation. Okay, you have to just remember this equation only. You don't want to remember the already derivation and all. Okay, it is not needed. So this is the electromechanical torque equation. Okay, and let's see what happens at starting. So we know that at starting the value slip will be very high, correct? Very high, because slip equation S is equal to what? Ns minus n divided by ns. At the starting, this n will be nearly equal to 0 or n will be very low, so that s will be very high. That is why the slip will be very high at its starting. So let the denominator term know alpha square plus s square. Alpha square plus s square, that is alpha square plus s square nearly equal to s square only, because s is very high, because s is very high than r2 or alpha, simply alpha. S is very high than alpha, because at the initial r2 will be r2 by x2, that is alpha compared to alpha, s will be very high. So this alpha square plus s square nearly equal to what, my dears? S square only. So this equation will become TE equal to some constant kt into s into e1 square into alpha whole divided by x2 into s square plus alpha square, that is simply equal to what? S square only. So it is simply s square. Correct? S square. This s and this one is cancelled. In this equation I can write like TE proportional to 1 by s. Correct? Am I correct, my dears? Am I correct? Because kt is a constant. You know this, kt is a constant. 60 into 3 divided by 2 pi n is a constant. E1 is nothing but the applied voltage, right? From nearly equal to applied voltage, that also we won't change. So that's also constant. Alpha is nothing but r2 by x2, correct? Let alpha is equal to what? r2 by x2, that also constant. And x2 is nothing but the, again, and reactance is also constant. So the only variable t is not, here it is nothing but slip, right? So T proportional to 1 by s, correct? T proportional to 1 by s. And we know, I can write like s is 1 by proportional to n, is it correct? Because whenever we see the slip equation, whenever we increasing the speed, the slip will decrease, correct? Whenever we increasing this term, this ns minus n will be reduced. So s and n will be inversely proportional quantities, correct? S and n will be, my dears, inversely proportional quantities. So I can write like T proportional to what? N. T proportional to n. So at the starting, T proportional to 1 by s or T proportional to n. So let's observe the incident at the starting. Suppose it is a 500 rpm machine. Suppose the synchronous speed is 500 rpm. You assume. And the normal running speed or rated speed let be 1440 rpm. You assume this parameter. Okay. Let ns be 1500 rpm and n be 1440 rpm. You switch on the supply. Okay, I switched on the supply. Will the motor suddenly goes to this 1440 rpm? Will it go? No. It will take some time. What the time? It has to start from inertia, that is 0. It's a 0 speed to speed to 1440 rpm. Correct? It will happen in 2 or 3 seconds. It will happen in 2 or 3 or maximum 5 seconds. It will happen. Depending upon the capacity of the machine, it will happen. So that time, the speed is very much fluctuating, because 0 speed to reach to what? 1440 rpm. So at the starting time, the speed is very much fluctuating. The speed is very much fluctuating. That means TE will be very much fluctuating, because T is directly proportional to N. That is speed of the rotor. So T is very much fluctuating with the very much fluctuating, very much fluctuating. So at the starting, TE will be very much fluctuating, or we can say that this is a unstable region. Very important. Unstable region. This is a unstable region, because of T proportional to N. That's why it's very unstable. So it's very unstable. Correct? So only point here you have to notice that T proportional to 1 by s or T proportional to N at the time of starting. And this is a very highly unstable region. This is very highly unstable region, my dears. Very high unstable region. Am I correct? Okay. And next, at normal speed or full load. At full load, or rated speed. Or rated speed. What happens? What happens? Let's see that also. We have the equation TE, correct? We have the equation TE equal to some constant KT into S into, correct? E1 square into alpha divided by, what is that? X2 into S square plus alpha square. You have to remember this equation, my dears. If you do with me for 2-3 times now, if you write along with me in your paper, definitely you will be remembered forever. Okay, definitely initially it will be very difficult. I know that, but we have to study, we have to crack the exam, we have to study this. Okay, so it will become KT into S into E1 square alpha divided by X2 square plus. That is the equation. So what happened, my dears? At a full load condition, N will be nearly a constant, correct? N will be nearly a constant. That means it will be a rated, correct? Rated speed, correct? Rated speed. N will be nearly a rated speed condition. That is, N attains its normal speed. N attains a normal speed. So slip will be very low, correct? Because N is normally 1440 RPM. It reached up to 1440 RPM. Then only we can say that it is a rated speed. Or it is at full load condition. No, it is at a full load condition. So at a full load condition, the slip will be very low. So the denominator term S square plus alpha square, my dears, it is nearly equal to alpha square only, not S square. Not S square. Because compared to S is very, very low than alpha. That is why this happens. S square plus alpha square, what? Equal to alpha square, or nearly equal to alpha square. So our torque equation will become TE equal to, what is that? KT into S into E1 square into alpha all divided by X2 into alpha square. This S square plus alpha square is simply what, my dears? Simply alpha square. So this alpha and this one alpha got cancel. So TE proportional to S. T proportional to S. Correct? T proportional to S. Is it correct? That means I can say that T proportional to S is nothing but what? 1 by N. 1 by N. T is inversely proportional to 1 by N. This also I can write like, this also I can write, correct? So at a full load condition, the N will be equal to what? Constant, right? N will be equal to constant. That means the torque will be nearly constant. Torque will be what, my dears? Nearly constant. That means this is called the stable region. This is called the stable region. So T proportional to 1 by S is called the unstable region or the starting region. T proportional to S is called the stable region, correct? Or full load region. Okay, did you get the idea? Did you get the idea, my dears? Did you get the idea? Did you get the idea? Okay. Learn the concept and move on. Okay, don't fear. Don't fear. The books and all are human written, right? If they can write a book, we can learn that also. We can learn that also. If an author can write a book, we can learn that also. Okay? So, starting torque. Next heading is starting torque. Next heading is starting torque. Listen, my dears. We have the equation for electromechanical torque T is equal to KT into S into E1 square into alpha divided by X2 into alpha square plus S square. Am I correct? Am I correct? So at starting, what happens? This alpha square plus s square nearly equal to what? S square, correct? Correct. So it will become TE at starting will be equal to T start. I can represent like T start. T start will be equal to KT into S into E1 square into alpha divided by x2 into S square. S and S will get cancel. KT into E1 square into alpha divided by x2 into S. Am I correct, my dears? And at starting value of S will be equal to what? Nearly equal to 1. So we can take that also. So T start will be equal to what? KT into E1 square into alpha divided by x2. Correct? So I can write that TST proportional to V square. Correct? Because E1 square, E1 is directly proportional to V1, right? V1 is the applied voltage, right? So simply you can say that T start proportional to V1 square, correct? And also T start inversely proportional to 1 by x2. Am I correct? T start inversely proportional to 1 by x2. Or I can write like T start proportional to R2. Correct? Because alpha is equal to nothing but R2 by x2, correct? So inversely proportional 1 by x2 square, that is correct, because alpha having R2 by x2, right? So x2 into x2 square. So T star proportional to R2. Or I can do one thing also I can write. See, my dears, we have KT will be equal to what? 60 into 3 divided by 2 pi into ns, correct? Or I can write like 60 into 3 divided by 2 pi into ns is nothing but 120 into f by p, correct? Or I can write like KT inversely proportional to 1 by f, correct or not? KT inversely proportional to what? 1 by f, correct? KT inversely proportional to 1 by f. And x2, in denominator x2 also, so TST I can write like 1 by f square. x2, so f cube. I can write like this. Did you get the idea? Did you get the idea, my dears? Starting torque will be inversely proportional to 1 by f cube. Did you get the idea? I will tell you. This alpha contains R2 by x2. So denominator will be x2 square. x2 is nothing but what? Inductive reactance is nothing but L into omega. Or it is nothing but L into 2 pi f. x2 square means f square, correct? x2 is directly proportional to f now. So x2 square means f square. So denominator will be f square. And due to this KT, there is one terms in the denominator as f already. So f square into f into f square will become f cube. Carefully note the term. Am I correct? Carefully note the terms, my dears. Am I correct? Am I correct or not? Carefully observe. Clear? So that is the condition for, or that is the the parameter which is connected at the starting time. So the starting torque directly proportional to V square, starting torque directly proportional to 1 by x2 square, starting torque directly proportional to R2, starting torque directly proportional to F cube, frequency Q. These things you have to remember. Otherwise, you simply remember this equation bus. You can directly substitute this equation and you will learn by yourself. No, you can make equation by yourself. No need to remember all this. You just remember this equation and you have to know what happened at starting. Okay, at starting this and this will happen. Okay, things will be over. Okay, next at full load or simply full load torque. Again, we have the basic equation. T is equal to KT into SC1 square alpha divided by x2 into alpha square plus equal. So at full load condition, what was our assumption? Alpha square plus s square nearly equal to what, my dears? alpha square, because S will be very low. At full load condition or nearly stable point condition or nearly stable condition, what happens? This S will be alpha square plus square will be nearly equal to what, my dears? Alpha square only. So what will be the result? What will be the result? TFL, I can write like TFL will be equal to some constant KT into S into E1 square into alpha whole divided by x2 into alpha square plus f square will be simply alpha square. And S will be, what is the value of S at starting? What is the value of S, I mean at a full load condition? What is the value of S at a full load condition? This S will be equal to nearly equal to 0, my dears, nearly equal to 0 or very low condition, I mean very low value, correct? The full load torque will be very, very low, correct? The full load torque will be very, very low. So what I can write? TFL directly proportional to what? Slip. You can write like that, or I can write like, again it is alpha and 1 alpha square, correct? This alpha contain an x2, right? Correct? This alpha contain what? R2 by x2. So this x2 and this x2 got cancelled, though there is no terms in the x2 side. So only this KT term is there, right? KT is there. So 1 by f. TFL proportional to 1 by f, correct? And TFL proportional to TFL inversely proportional to 1 by R2, correct? 1 by R2. 1 by R2, because this alpha contain R2 by x2, no? This x2 and x2 cancel, but alpha is there. Alpha is there. Alpha is there. So that's all about. Okay. And TFL also directly proportional to A1 square. A1 square. So these are the conditions, or these are the peculiarity, or these are the important things you have to note always. You start the machine, when you start the machine and at a full load condition. See, the full load torque is very feeble, very low. It will clear when we draw this torque slip characteristics, it will be very much clear. The full load torque is very much low, very much low. The motor having very high starting torque, I mean starting torque will be high of course, and there will be some maximum torque, and after that it will come to full load torque also, right? So the full load torque will be very less. So that's all about the starting torque and load torque, okay? Do you get the idea? I know these derivation part and all, you will be definitely bored, but we have to learn, my dears, we have to learn this. Otherwise it's very difficult. Because by solving problem and all, by solving objective question especially, you need to know all this. You need to know all this. You need to know all this. Next, maximum torque. This is very, very important. This is very, very important, my dears. Maximum torque. Maximum torque. See, we have the basic equation for electromagnetic torque as KT into S into E1 square into alpha whole divided by x2 into alpha square plus S. Am I correct? Am I correct, my dears? So I am going to take this S denominator as denominator. So KT into S into E1 square into alpha divided by x2 into this. I am take S square outside. So it will be S square divided by alpha square divided by S square plus 1. Correct? The equation is correct, my dears. This S and S will cancel. So it will become KT into E1 square into alpha whole divided by x2 into S into alpha square divided by S square plus 1. That is nothing but T. So for maximum torque, we already learned this. The denominator, that is d by, the term will be varying is S. D by d denominator correct? For maximum torque, the denominator, derivation of denominator also equal to 0. For maximum and minimum it is applicable. For maximum and minimum, it is complete. Either you can differentiate the full term d by ds of the torque is equal to 0 if the numerator and denominator both contain variables. If the denominator only contain variables, then why we have to waste time? Why we have to waste time? We only go for the denominator term. First, simple mathematics. Simple mathematics. Here you have to know maths. In electrical engineering, this is the toughest branch in engineering, and this is the toughest degree, graduate degree. So be proud that you are learning a very toughest thing in the world, very toughest thing in the world. Clear? So mechanical is there, civil is there, computer science is there. So compared to all other branches, EEE is the most difficult branch. You have to apply a lot of things there. And unluckily, we have less vacancies also, right, for some examination and all. Like software profession, it will take bulk quantity of graduates, but we are not. But if you get a click there, superb job. You can see, in my view, my dears, actually I was in teaching profession for 8 to 9 years, nearly 8 to 9 years I was in teaching profession. And I decided, okay, teaching is a very good profession, I know that. But if you really love your subject, teaching, of course, you can go. Definitely you can go for teaching if you're really passionate on teaching. Because, conveying the knowledge is a very big thing. So you can go for teaching, of course. Otherwise, my advice is that don't go for a job which is not suitable for your graduate degree. Correct? Then how will you get what? You joined EEE, I joined actually EEE for, just I felt it. I really was passionate on that EEE, on that subjects. I was really in love with currents, electricity and all. So that's why I took electrical engineering. So I know definitely all people will be like this, right? Definitely like this. So please forward your career journey on EEE related field only. Don't switch. Okay? There may be difficulties. There may be some pressures from the family side or relative side or from the society. Don't quit until you face the victory. It may take time, my dears. It may take time. You may work hard for 2 to 3 or 3 to 4, 4 to 5 years to get cracked or to get into the electrical field job. But once you cracked it, you can proudly say that I am an electrical engineer. You can proudly say that. Okay? So try hard for that. Put your effort. Definitely the result will be there. Okay, where we stopped? For maximum torque, d by ds of denominator will be 0, right? Because the only variable here is s, slip. So it will become ideas. It will become t. Yes, I can say like d by ds of, what is denominator? x2 into s into alpha square divided by s square plus 1 equal to 0. Am I correct? My dears? So it will become, so denominator will be equal to 0. It will become, x2 is of course a constant, right? So you can take it outside. So d by ds of s into alpha square divided by s square plus 1 equal to 0. What I get? It is a two functions, right? So first function into d by ds of second function. What is that? Alpha square is a constant, minus 1 by s cube, correct? Plus 1 is a constant, no need to count. Plus alpha square by s square plus 1 equal to 0, correct? Where is that? Small confusion. x2 into, yes, why I have to waste my time? Why I have to waste my time? You can directly multiply, no? You can again simplify this equation, right? Just a minute, my dears, just a minute. You can again simplify the equation like T will be equal to KT E1 square alpha divided by x2 into, correct? Yes, x2 into alpha square, this and this s will be again, correct? You can multiply inside, correct? Alpha square by s plus s, correct? Alpha square by s plus s, correct? So it will become d by ds of alpha square by s plus s is equal to 0. This x2 is a constant, you can take it outside and it will vanish. No need to do that. It will become z alpha square by s square d by d minus alpha square by s square, correct? Correct? Plus 1 is equal to 0. Or I can say like 1 equal to, my dears, alpha square by s square, correct? Or I can say that s square equal to alpha square, or s will be equal to alpha, or s will be equal to, what is alpha? R2 by x2. Very, very, very important relation. Very, very important relation. That is the slip at which maximum torque happened is that R2 by x2. This is nothing but, I will write here, slip at which maximum torque happens. Slip at which maximum torque happens is that S is equal to R2 by x2. So simply put in slip equation as S is equal to R2 by x2, what I get? T max will be equal to, when I put S is equal to R2 by x2, T max will be equal to what, my dears? KT into E1 square, alpha is nothing but S, correct? S divided by x2 into S again S into alpha is again S, correct? Alpha is again S, so S square by S square 1 plus 2, correct? S and S cancel. Simply, my dears, T max will be equal to KT into E1 square divided by 2x2. Very, very, very important relation. KT into E1 square divided by 2x2. KT into E1 square divided by 2x2. That is the equation for maximum torque. So by observing this maximum torque equation, we have to learn something. That is one. First one, T max will be inversely proportional to 1 by F square, correct? Because this K2 contain 1F as denominator, X2 also contain 1F. So it will be equal to 1x2 F inversely proportional to F square. And one more thing you have to know, T max is independent of R2, X2. X2 is there, independent of R2 and slip. T max is independent of R2 and slip. Correct? T max is independent of slip and R2, but the slip at which maximum torque is dependent upon R2 and X2. Correct? You have to note the difference. T max is independent of R2 and S2 means many slips you will get a constant T max all the time. The value of T max will not be changed. If you vary the slip, increase the slip, decrease the slip. If you vary the R2, increase the R2, decrease the R2. The value of maximum slip will not be changed. But the slip at which maximum slip happen, maximum torque happen is dependent upon R2 and X. That means the slip may be varying depending upon R2 and X2. But the torque is independent of slip and R2 values. The torque is independent of slip and R2. Am I correct? Am I correct? So that is the condition for maximum torque. Now in direct objective you may ask a question like this. What is the condition for the slip for maximum torque? S is equal to alpha. or S is equal to R2 by X2. X equal to R2 by X2. Or alpha or R2 is equal to Sx2. In many ways you can say. In many ways you can say. Next. Effect of rotor resistance in torque slip Chara. Listen, my dears. We will learn the thing graphically, okay? We learned. Correct. These three things you have to notice. You have to bus. Draw this figure, my dears. Draw these figures. A single graph itself give you a lot of information. A single graph itself give you a lot of information. A single graph will give a lot of information. Not this. Not this, my dears. Not this. See, we have to learn effect of rotor resistance in torque slip Chara. What happens when rotor resistance increase or decrease? What happens? We will learn. We are going to learn. So this is the torque slip characteristics. So y-axis is the torque, x-axis is the slip. This is the point at which starting. So this is the starting point. So we know that at starting slip will be equal to 1. So at a particular value of R2, say a resistor R2, at a particular value, R2 is nothing but the rotor resistor, correct? A particular value of rotor resistor, say the T start 1 will be the starting torque. Say here it is in the mid, and it is slowly increasing. The torque will slowly increasing, and it will reach the maximum value, right? So at maximum value, what happened? This R2 will be equal to S into X2, right? R2 will be equal to S into X2. At a maximum point, R2 will be equal to S into X2, correct? That is the maximum point. And after again you increasing the torque. So this point, up to this point, you know, the maximum torque point is called the pull-out torque. Is called the maximum torque. Maximum torque, that is called the pull-out torque. If you increasing the load again increase it, up to which it will bear the maximum torque, right? Maximum torque, or we can say it like a pull-out torque. After that, if you increasing, the torque will be suddenly false. The torque will be suddenly false. So up to this point, so this is called the pull-out torque. This point is called the pull-out torque. After pull-out torque, the torque start decreasing. After pull-out torque, the torque will reduce or decreasing, and it finally goes to. That means when the slip is nearly equal to 0, this point is nothing but, my dear, slip is equal to 0. Slip is equal to 0 is nothing but when the rotor speed and the synchronous speed matches together. It will never happen actually, but in graphical representation you can represent. A small variation will be there, of course, that also will lead to a very low value of torque, because ns minus n, the difference will be very low. That means the slip will be nearly equal to 0, or slip will be very low. When the slip is very low means you can't do nothing. The torque will be very low. So this region is called the T proportional to 1 by S region, highly unstable region, starting time, correct? This portion is called after full load, no? After full load up to some time, not up to this level, but this region we can say that T proportional to S region. This is called the stable region, correct? This is unstable region and this is called the stable region. And this is called the stable region. It's called the unstable region. Is it clear, my dears? Is it clear? Okay, come back to our point. Our point was not the stable and unstable region, correct? What is the effect of R2 on the torque? That is our aim, correct? Come back. Okay, and what I am going to next time, I increased my resistor from R2 to R2 dash. I increased my resistor. If you increase the resistor means definitely the starting torque will be increased. That is a function of adding some resistance in the slip ring induction motor in order to increase the starting torque, correct? So when you increasing the resistor R2 dash, that means R2 dash will be greater than R2, correct? R2 dash will be greater than R2. If you increasing the resistor, what happens? Again, the starting torque will be increased. That is why it is somewhat here, not here, from here, it is higher than the starting torque 1. So it is higher than starting torque 1, starting torque 2 started. Again the same parameter, you came here and came here. Again this is R2 for R2 dash. You observe one thing, this maximum torque, and even if you increasing the value of rotor resistance, the maximum torque is not varying. That you learned in the last session. The maximum torque is independent of radius. The maximum torque is independent of R2. Even if you increasing the R2, only the starting torque will vary, but the maximum torque doesn't depend upon R2, my dears. See the constant, it is T max is constant for this value of R2, this value of R2, this value of R2. It's not varying. That means it's a constant. It's independent of R2 bus. It's independent of R2 bus. Again, you decrease the resistance. Say it is R2 double dash. You decrease the value, least resistance R2 double dash. What happens? It may start from here because the starting torque is less compared to the first stage. TST1, it is again lower than TST1 now. So it will be TST3. It is slowly increasing its maximum value again come back. Here also it attains the maximum value. The same maximum value will attain by both the, three resistors. If you vary 3 resistors, the maximum value will be same because T max is directly proportional to, is independent of R2 bus. Correct, my dears? KT into E1 square divided by 2x2 is the answer. It is dependent upon only x2. Correct? Correct. But the slip at which maximum torque happens is varying, because slip is dependent upon S is equal to what? At maximum of R2 by X2 will be there, no? So the slip at maximum torque is varying. See, for very high value of, initial value, see R2 dash, a medium value. For very high value of resistor is nothing but R2 dash, correct? High value of resistor. Most high value of resistor is R2 double dash. See the slip at which maximum SMT2. Slip also maximum. The slip at which maximum torque happened also maximum slip. And T least value of resistance TST3. See this, the slip at which least value of but the torque least value of resistance happened, the maximum torque is at least slip. The slip also very less there. That means if you increasing the R2, you have the slip also very high for maximum torque, right? The maximum torque, slip at which maximum torque happen also very high. If you decrease R2, then the slip at which maximum torque happens also very low. Very high, very low. Compare my dears, and learn. Okay? Got dear? Did you got this? You got my idea? Okay? When I was a student, when my teacher took the session, it was like, it was like a graph. Teacher draw some lines and all. Teacher explained and she went. Actually, she know everything, no? She's our teacher, definitely. She know everything. But as a student, we didn't know anything. We simply ideally settled for okay. And for examination, what we did? We simply by heart this step, by heart the graph and went for exam. Okay, I think 80%, 90% of the engineer's life will be like this. When we were a student, we don't know much about the concept. We simply prepare for examination point of view. After that, if you don't get any job, what happens? You start learning. At that time only you will clearly understand what was happened in machines, in control system, in measurements. You start. Actually, the learning process start from, in engineer's life, the learning process start from after graduation. In my view, in my opinion, actually the learning process start from after graduation. Okay. I hope your condition also similar. Okay. Comment your answer if it is slightly varying. Okay. Next, torque slip characteristics, very important. Torque slip characteristics. Torque slip characteristics. Okay. Just draw, my dears, just draw the figure. Torque slip characteristics. See, this is not a new thing. You know the torque slip characteristic is equal to 1 for it will increase and it will decrease, right? You know this starting torque and maximum torque, right? Full load torque, right? Not maximum torque, it is a full load torque. Full load torque means when it is near to when the machine attains its original speed, that is the full load condition. That's the full load torque, okay? SFL, this is nothing but the slip at which maximum torque happen, S is equal to 1, S is equal to 0, you know this. This region is called the motoring region and this is called the braking region. Why it is called the braking region means, in braking region, S greater than 1. S greater than 1, this is S equal to 1 and this is nothing but S greater than 1. S greater than 1 means, my dears, what? N will, this is the equation for S, right? This will happen greater than this one. What happened? S will be, slip will be what? In magnitude wise, slip will be greater than 1. Correct? Slip wise, magnitude wise, slip will be greater than 1. That's all. That's for braking region. So braking region means nothing but we have to what? We have to increase the N. I mean the reverse process actually, right? The reverse process. S is equal to Ns minus N by Ns. If the value of slip is greater than 1 means the only possibility here for greater than 1 will be what? What? Increasing this one. Increasing this beyond that Ns. Beyond that Ns. Okay, so braking and all we will learn later, so just understand, okay, it's greater than 1 is braking region. Similarly here also will happen something, but torque is in reverse direction means it is a generating region. It's a generating region. Generator, the induction generator and all, it will cover this section. Not that much important these parameter and all. You just learn these T proportional S is called the stable region, T proportional S is called the unstable region, motor region, and simple just know these regions. Braking region, correct? And all. Okay. So that's all about the torque slip Chara. So that's all for today, my dears. So in the next class we will learn some more problems regarding this induction motor. Okay. So bye for now. We will meet again tomorrow. Bye.